Good day, everyone. My topic is all about humidity, geographic distribution, time variation, and measurement. So objective, to understand how to measure humidity. What is humidity? Humidity is the amount of water vapor in the air. If there is a lot of water vapor in the air, the humidity will be high. The higher the humidity, the wetter it feels outside. So, the higher the humidity, the greater the water vapor, and more rain we're likely to see. Humidity, therefore, is a very important part of the weather, governing how heavy a rain shower is or how comfortable it feels on a warm day.
Humidity is the amount of water vapor in the air. Water vapor is the gaseous state of water and is invisible. Humidity indicates the likelihood of precipitation, dew, or fog. Higher humidity reduces the effectiveness of sweating in cooling the body by reducing the rate of evaporation of moisture from the skin. This effect is calculated in a heat index table or humidex. The amount of water vapor that is needed to achieve saturation increases as the temperature increases. As the temperature of a parcel of air becomes lower, it will eventually reach the point of saturation without adding or losing water mass. The differences in the amount of water vapor in a parcel of air can be quite large. For example, a parcel of air that is near saturation may contain 28 grams of water per cubic meter of air at 30 degrees Celsius, but only 8 grams of water per cubic meter of air at 8 degrees Celsius. There are three main measurements of humidity: absolute, relative and specific. Absolute humidity is the water content of air at a given temperature expressed in gram per cubic meter. Relative humidity, expressed as a percent, measures the current absolute humidity relative to the maximum highest point for that temperature. Specific humidity is a ratio of the water vapor content of the mixture to the total air content on a mass basis.
So, humidity tells you the moisture content of atmosphere, or how much water vapor there is in the air. When the humidity is high, it feels oppressive outside because a sweat doesn't evaporate and provide cooling. A high water vapor content is necessary to produce clouds and precipitation. So, these are the three primary measurements of humidity are widely employed. First, the absolute humidity. Second, the relative humidity. Third, the specific humidity. Absolute humidity. Absolute humidity is expressed either mass of water vapor per volume of moist air in grams per cubic meter, or as mass of water vapor per mass or dry air, usually in grams per kilogram. Absolute humidity is the total mass of water vapor present in a given volume or mass of air. It does not take temperature into consideration. So, absolute humidity is measured weighing the water vapor in grams contained in 1 cubic meter of air. This, however, is not a very useful parameter in meteorology. It is more important to know how much water in it is potentially possible to obtain in the form of rain from a given quantity of air.
First talk about absolute humidity. Absolute humidity is the mass of the water vapor which is present per unit per volume of the air. So now absolute humidity is measured in grams per cubic meters or cubic centimeters. So that's how we understand absolute humidity. That means if the volume of the air parcel changes, it would affect the absolute humidity, and therefore absolute humidity is accounted by the changes in the volume of the air parcel. However, it does not take into consideration the temperature changes. Now, absolute humidity usually ranges from 0 to around 30 grams per centimeter cube at a temperature of around 30 degrees Celsius that we consider as a basic temperature.
Next is the relative humidity. Relative humidity, often expressed as a percentage, indicates a present state of absolute humidity relative to maximum humidity given the same temperature. In other words, relative humidity is the ratio of how much water vapor is in the air and how much water vapor the air could potentially contain at a given temperature. It varies with the temperature of the air. Colder air can hold less vapor, so changing the temperature of air can change the relative humidity, even when the absolute humidity remains constant. So, relative humidity, expressed as a percent, also measures water vapor, but relative to the temperature of the air. In other words, it is a measure of actual amount of water vapor in the air compared to the total amount of water that can exist in the air at its current temperature.
Relative humidity. Now, since it's relative, it's expressed in percentage. So that's the key aspect here. Now, this could be 100%, that means 100% saturation is there, and 0%, that means it is not at all saturated. So, relative humidity is expressed in percentage. This relative humidity is affected by both changes in temperature and amount of water content. So, it's a function of both the water content and the temperature that's present. However, absolute humidity was independent of the temperature changes, but it varied with the volume that was given. So, relative humidity, I can explain, it's the ratio of the partial pressure that's present of the water vapor divided by or present in a mixture where you have a saturated vapor pressure that's given. So, vapor pressure for a saturated content that's given would be the base value. So, that's how we calculate the relative humidity. The partial pressure divided by the saturated vapor pressure would be the relative humidity.
Specific humidity. Specific humidity is the ratio of water vapor mass to the total moist air parcel mass. Specific humidity or moisture content is the ratio of the mass of water vapor to the total mass of the air parcel. Specific humidity is approximately equal to the mixing ratio, which is defined as the ratio of the mass of water vapor in an air parcel to the mass of dry air for the same parcel. So, the specific humidity is an extremely useful quantity in meteorology. For example, the rate of evaporation of water from any surface is directly proportional to the specific humidity difference between the surface and adjoining air.
Humidity and mixing ratio. A lot of students are confused between the differences in specific humidity and mixing ratio. So when I say specific humidity, I am talking about the ratio of the mass of the air parcel to the total air parcel. So mass of the water vapor that's present divided by mass of the total air parcel. However, when it comes to mixing ratio, I'm
Next, hygrometer. Hygrometer is an instrument used in meteorological science to measure the humidity or amount of water vapor in air parcel mass. So, many dermatologists and cosmetologists advised to humidify the air indoors to make skin fresh and healthy. Breathing clean air with comfortable temperature and humidity help us uptake oxygen and transfer it through our blood vessels much easier. This, in turn, results in reduced fatigue and higher concentration.
In this video, you will learn how to use a hygrometer. Hygrometers are used to calculate the level of humidity in the air. This level is given as a percentage. In your home, the humidity level should be between 40 and 60% for the ambient air to be comfortable. Low humidity levels, below 30%, can cause an increase in static electricity, discomfort, irritation, or an increase in the concentration of dust in the air. High levels of humidity, above 70%, encourage the multiplication of microbes, the appearance of mold, and condensation on cold surfaces. When the temperature remains constant, you will feel the cold more when the humidity level increases. To dehumidify the air and feel warmer in your home, get into the habit of airing your home for 10 minutes each day. You can also reduce the humidity level with an electric fan or ventilator. Buying a hygrometer isn't an expensive investment. You can find one in the shops, costing from around £4. Now you know how to use a hygrometer.
That's all. Thank you.